Over the last few weeks, I've been getting a lot of questions about time. It's coming up from whether it's school boards, school districts, teachers, asking about time, about how many minutes. Is it really important to give a lot of time for mathematics? Can we take a math class and can we split it in elementary school into 2 chunks? Take that big block and have maybe time in the morning, time in the afternoon. What's the effect of having a 4-day week versus a 5-day week? And what happens over the summer? Is that really detrimental? And so I was thinking, I'm pretty sure the more minutes would be better, but I wanted to go back to the research and see what is clearly important, what's not, and I found some really amazing things. So time does matter. The amount of instructional minutes to build deep understanding so kids remember things over time is critical. Okay, so we're going to talk about what's happening with the brain. That's the important whys. What's happening with those minutes, that's really critical, so the instructional cycle. And then we'll talk about 4-day weeks and summer school. Okay, so what's happening in the brain? So one thing that's really important is that with young kids, especially elementary kids, we need time to really build their sense making. There's a lot of issues with workload and working memory. So we need to be able to do different things during the day to really build a strong schema, strong understanding of the mathematics. Okay, so we need to be able to really work on the kids' working memory, and really that's also the attention span. So it's really critical that we actually extend the number of minutes during the day. So that's going to help build this rich understanding of the mathematics. We also need to include, as Jerome Bruner talked about, inactive, iconic, and symbolic situations. So we're actually have time to build the mathematics with concrete situations. We need to have visual models that really puts in for long-term success is when we have those visual models, and then we work on symbolic models and we connect those 3 together. To start a lesson, we really have to activate our prior knowledge. We have another research overview on this, a DMT insight on how important prior knowledge is. You can check that out. So when you activate the prior knowledge, that's really getting their schema to really understand and make connections. Then we need that time in the classroom to expand these ideas, to build the inactive, iconic, and symbolic representations. So you need time for that. You also need time for discussion. You need to have kids collaborate, talk out loud. We need to bring in language. We talk about structural language. We have a research overview on that too if you want to read why that is so critical. And so as kids are having conversations and exploring ideas, that's important. And then we need to have time for whole class discussion where the teachers bring in ideas back and asking kids what are these ideas and building that discourse. Then we do need to have time for very structured practice, and we need to end with some type of exit ticket so it really gets at the what I call the residue. Like, okay, we just ended this day. What is the gunk that's left over? Hopefully it's like, I really enjoyed the mathematics. I'm actually learning something versus I just did math and I don't like it. So those are really critical things. So that jumps into what is the learning cycle? What should that be? And how much time should I be spending? Well, this was really interesting. The research was for K2 saying about 70, 80, or even up to 90 minutes of time, sustained time for mathematics. By grades 3-5, it's 60 to 70 minutes, and by middle school, it's 50 to 60. But all of them still have to have components of this learning cycle. You want to start with that warm-up, where you're connecting to something for the prior knowledge, and it could also be some numeracy, some number fact ideas as well. Then you want to launch the idea, like what are we working on today? And then you want to have them have some discussion time. You might give them some words, have a word wall, have sentence structure, give them some language, and have them work on it in a group. And then as you move from group to group, you can really encourage them to extend some of these ideas. Then you're going to move into a whole class discussion, bring everybody back, summarize the ideas, and what we call progressive formalization. So again, another research overview on that if you want to check that out. The idea of progressive formalization is you want to take their ideas, their informal ideas, and you want to build on them, again, building their schema so that you're actually connecting ideas again. And then you're going to end with, oh, this is the one, or these are the 2 things I want you to work on today. And now we're going to do very intentional practice. And that practice could be in class. Sometimes it could also be homework, but a lot of schools feel like they don't have enough time. There might be an equity issue there, so not getting into that right now. But they do need to have that time for that varied practice and that very intentional practice. And then you want to end the day, just a quick summary. You might give them, I use the Patty paper, and I ask 1 or 2 quick questions that they can write their name, jot down the idea, and then they can turn it in, and then I can sort it really quickly into 3 groups to see if the kids are learning what I want them to learn. Or you could just have them all walk out saying one big idea from today. So they all have to be very explicit. Exit tickets are really pretty amazing. So with time, okay, this was another one that was really interesting. I was usually saying with a warm-up maybe 5 minutes, but the research was saying for young kids, it's actually better to do 10 to 15 minutes for kinder through 2nd grade. Then maybe just 5 to 10 for older students. That's really critical. The launch is only going to take a couple minutes, and then the discussion could be anywhere from 15 to 25 minutes, kids exploring ideas, 10 minutes back up at the board, and then 15 to 30 minutes for practice. So those are really critical ideas. Okay, then let's jump into summer school and the 4-day week. So what happens, a lot of times districts, because of busing, we're going to save some money, not on Friday, or we want teachers to have more planning time. All awesome ideas, but the research is clear. It is detrimental. Every day that you take off does have a reset. And so now, when you come back on Monday or wherever that first day is, you're spending more time on reteaching. So you're actually losing the mathematical understanding and proficiency levels. So it ends up being a little bit of a detriment. However, if you have assignments for them to work on Friday and Saturday at home, then that is awesome if you can do that. Okay, summer also, you lose 1 to 3 months, very detrimental. It is so critical, especially for kids in low socioeconomic status areas, communities, to have a program in the summer. We cannot have 1, 2, 3 months off. Huge fall in understanding and proficiency levels. So put them in some type of program, especially if they have different components that we were talking about with that launch of ideas, and then the different types of practice, and even better to have communication. So it's good if the parents can do that or if they're in a summer school program. So one of the amazing things is that Developing Mathematical Thinking Institute, we've created those components. We'd love for you to use them. And we also have an amazing summer school program that has incredible results, and teachers actually like teaching it, and the kids are excited about the mathematics because they're truly understanding. So we appreciate your time, and remember, time matters when building mathematical understanding and proficiency. So please like us, share this, and follow us for more information.